Okay, so with this session, we'll start off with some basic algebraic fractions, and then we'll try some more challenging ones and see how you go. So the first one we'll do to start us off is if we have x over 3 plus 2x over 5. Okay, so when we're adding fractions as normally or subtracting, we know we have to have the same denominators. So I'll just times 3 by the 5 and 5 by the 3 to give me 15. But what you do to the bottom, you must do to the top. So times by 5 there and times by 3 there. So we're left with x times 5 is just 5x over 3 times 5 is 15 plus 2x times 3, well 2 times 3 is 6 and the x just sits there over 15. And now you add in this extra step that's important when it comes to algebraic fractions. We have 5x plus 6x all over 15. Okay, and now can we add the 5x and the 6x? If we couldn't, we just leave it that way. But because we can, because of this, like apples with apples, we have 11x over 15. And check and see, can we simplify 11 and 15? No, we can't. And that's our final answer. Now, question 3, you notice that with our denominator, we have an a here. So what's missing on this side? Now remember, a is a number. A could be 2, it could be 4, who knows what it is, but we're saying 2 times this number. So we need to have that same number being multiplied with this 2 here to make it the same. So all we have to do is times the 2 by a and times the 4 by a. What you do to the bottom, you do to the top. And don't get confused, a is just a number, but we don't know what it is. So we will be left with 3 over 2a plus 4 times a is 4a, and 2 times a is 2a. Now that our denominators are the same, it's the same number. Like I said, imagine if a was 5, we would have 2 times 5, which is 10, and 2 times 5, which is 10, the same number. But we don't know what a is. So now, do that extra step, write it over the same denominator. We have 3 plus 4a. Now, can we add the 3 and the 4a? No, we can't. They're two different terms, so we stop there. But another question is, can I simplify my 2 and my 4? They're both even, so can I cross that off and write 1 and write 2? The answer is you can't do that, because see how there's a plus separating the 3 and the 4a? That means they must all be divided by 2, because if you go back a step, we actually have 3 divided by 2a and 4a divided by 2a. They're both getting a turn to be divided by that 2 and the a. So if I did this, I'm making a big mistake, because I have to also divide 3 by 2. And if I go 3 divided by 2, I know I get a decimal. So the final answer would be 3 plus 4a over 2a. And we stop there, because whenever you have addition or subtraction separating two things in fraction form, you can't just simplify 1 and 1. It must be everything. Everything must get a term. But if we had 4a over 2a, just say, see how this is different? See how the 4a and the 2a are both joined by times and they're not separated by a plus or takeaway? In this case, yes, you could cancel out the 4 and 2 and end up with 2a over a, and also cancel out the a and the a and end up with 2. So here we couldn't do that. We couldn't cancel the 2 or the 4 or the a and the a unless we also give the 3 a turn as well. Okay, try this question first and then watch the solution. Now, with our denominators, we've got a, b, c, and here we got a, b. So what is missing from this side here? I'm missing a, c. So all I have to do is, well, times this side by the number c, or variable c, and times the top by c. So we end up with 3 over a, b, c, plus, we've got 2 times c, which is 2c, over a, b, c. Because a, b times c is just a, b, c. And now that we have the same denominator, we write them both under the same denominator, so a, b, c. And 3, we've got a plus here, so 3 plus 2c. Can we add 3 plus 2c? No, we can't. And that is our final answer. And we also know we can't cross off the c and the c, because the 3 must have a c next to it as well. So stop there. Now, with this question here, they're starting to get more tricky, but this is just just as easy as the other ones. So try and have a go. If you find it too challenging, then you don't have to do it. But we got 6 and 3 on the bottom as our denominators. And on top, you notice we have x plus 1, and then on this side, x minus 1. Whenever you see this, I want you to put brackets around the x plus 1 and the x minus 1 to start you off. That is saying x plus 1, they're a number. It's a number, and they can't be separated. The problem is we don't know what x is, and so they're stuck like this. And the same on this side. So always put brackets as your first step. Now, what we have to do is make our denominators the same. We've got 6 here and a 3. I know I can turn my 3 into a 6 by multiplying it by 2 and also multiplying it by 2. And now this is a tricky part. And what I want you to do before you expand this, I want you to write it out under the same denominator. So we're going to have, that's going to be a 6. And so we're going to have everything over 6. So we have x plus 1 on one side, bracket, plus, and now see how we're multiplying the x minus 1 by 2. Can you please write the 2 outside the bracket and write x minus 1? Okay? And now you can see what will happen. By doing that, we know we have to now expand the brackets. The 2 times the x and the 2 times the minus 1. That's why it was so important to put brackets around it. So now we have, now this x plus 1, the brackets don't have to be there anymore. We just have x plus 1. There's nothing on the outside to multiply it with. Plus, well, 2 times x is 2x. And 2 times minus 1 is minus 2 over 6. And now have a look at your top terms. Is there anything we can simplify? Anything we can add? Well, I've got an x here and a positive 2x. Well, 1x plus 2x, that's just 3x. And I've got a positive 1 minus 2. Well, 1 minus 2 is minus 1. And they're all over 6. I'll just squeeze it in. And that's your final answer. And remember, you cannot simplify that 3 and that 6. Okay, our next question. We don't have brackets in this one, so it shouldn't be too hard. You notice on the bottom we have a squared, and here we've got a. So I have to make these two denominators the same. And I know I'm saying a times a here when I have a squared. So all I've got to do is times this side by a and the top by a. And this side can stay the same. So I'm left with 3 over a squared plus 6a times a, that is 6a squared, over a times a is a squared. I now have the same denominators, so let's write them under the same denominator. So I've got a squared and 3 plus 6a squared. And that is your final answer. And remember, you cannot cross off the a squared and that a squared because that 3 needs to have an a squared also. Now this question here is starting to get more challenging, and that is because of this negative. Now we know we still have to have the same denominators, and you'll see why this negative is very important in a second. So first step is put brackets around the top numerators because they're separated by subtraction in this case. So we're just saying that this is one number and that is another number. So x minus 1 can't just be separated. All right, so 14 and 7, to make them the same, I've got to times 7 by 2. And what I do to the top, what I do to the bottom, I must do to the top. All right, and now before you expand this, do not go 2 times x and 2 times minus 1. First, I want you to write it this way. So we know 7 times 2, that's going to be 14. So we'll end up with everything over 14. And you'll see why it's important you don't expand this just yet. So we have 3 minus x. I don't have to keep the brackets anymore because I'm not multiplying this side. Now, please write this takeaway, this negative. And now, do the same thing as before. Write down the 2 outside the bracket and x minus 1. If you don't do this important step, you'll notice what happens and you'll get your answer wrong. And that is, that negative is now a negative 2. So we're saying minus 2 times x and minus 2 times the minus 1. So it's really important when you do this, don't just go 2 times x and 2 times minus 1. You first write it this way so you can see that negative is saying minus 2. So we'll be left with 3 minus x, and then we have minus 2 bracket, we'll expand it. I'll just write this out. And minus 2 times x, that's minus 2x, And minus 2 times minus 1 is a positive 2. And it's all over 14. And we'll just see what we can simplify on top. Well, I've got a whole number here and a whole number down there. A positive 3 plus 2, that is 5. And a minus x minus 2x, well, minus 1 minus 2 is minus 3x. And they're both on top of a 14. And that is your final answer. So please make sure whenever you see a negative and you know you're going to have brackets on a certain side, just make sure whatever you're multiplying, you first write it this way, because that factor 2 is actually a negative 2. Now, for this question, you notice our denominators look kind of complicated. We've got an x minus 6 and an x plus 2. Please just remember x minus 6, put brackets around it if the question doesn't do that for you. X minus 6 is a number and x plus 2 is a number. For example, I could just have 3, imagine x minus 6. Imagine x was, let's see, 8. So if I had 8 minus 6, that would leave me with 2. And just say 8 plus 2 is 10. I'd have 2 over 10. Imagine we had that. Imagine x was 8 and we could work out what the numbers actually were. And if we had 2 and 10, we just have to multiply the denominators to make them the same. But we don't have that, but we'll be doing the exact same thing, multiplying our denominators with each other so they can be the same. So our next step is, I'll just change my color, is to multiply them with each other. So we're going to have, I'll just squeeze it here, this times that. So we're going to have times bracket x plus 2. And on this side, times the other number, which is x minus 6. And what you do at the bottom, you must do to the top. And x plus 2. And I'll just make this question a positive. You can work with a negative, but I'll make it a positive because it might be your first time doing this. And times x minus 6. And now, what our denominator will look like is this. We'll have a bracket x minus 6. Now, you can write times, but the times is invisible in between brackets. So x minus 6 and x plus 2. We're saying that times that. See how we had that times that and that times that there? And it's like saying 2 times the 10, but we don't know what the x is. And don't expand the denominators. You stop there and leave it this way. But now the top, we have to expand the top. So first, let's write it out. We have 3 bracket x plus 2, and it's a plus, and then 2 bracket x minus 6. And now with the top, we do expand the top to see what we can simplify. So we're going to go 3 times x and 3 times 2, and that's a positive 2, x times x and times a negative 6. So we're going to have the same denominator, and so 3 times x is 3x, and 3 times 2 is positive 6. Positive 2 times x is 2x, and we end up with minus 12, because 2 times minus 6 is minus 12. Now remember, we have the same denominator. I'm not writing it because I can't fit it all in. So our final answer will be 3x plus 2x, that is 5x, and positive 6 minus 12, that makes minus 6. All over the same denominator, x minus 6 and x plus 2. And that's it. So this was quite a challenging one, but just remember, when you put brackets around, in this case, x minus 6, that is just a number, and that is another number. And to have the same denominators, just multiply them with each other. And you don't expand the bottom. Leave it in factorized form. Thank you.